Hi, I'm Alexis Pito, a Bachelor of Secondary Education, major in Science. Before we start, let us have an overview first of the main concept of fluid mechanics. Fluid mechanics is a branch of physics that deals with the behavior of fluids at rest or in motion and interaction of fluids with solids or other fluids. Fluid mechanics is divided into two, mainly fluid statics, which deals with fluids at rest, with its density, volume, and specific gravity,
and fluid dynamics,
which deals with fluids in motion, which includes hydrodynamics and aerodynamics. The ideas of fluid mechanics can be applied in biomechanics, such as blood flow through the blood vessels, in the household, the piping systems for water and sewage, civil engineering, such as air and water pollution control, mechanical engineering, such as in the designs of turbines and pumps, and chemical engineering, such as in the designs of chemical processing equipment. In chemistry, we learned about the phases of matter as being solid, liquid, and gas. In this lesson, we have been focusing on the motion of solid objects, but there is much to be discussed in the way of fluids as well. A fluid is defined as any substance that can flow and alter its shape through its particles being to move around with respect to one another. In a solid, particles are fixed and compacted in a lattice, making it have a definite shape. Therefore, solids are not fluids. Liquids and gases are, for their particles move freely. And fluids have certain properties that are highly essential in physics. Certainly, any fluid will exhibit some density, which is taken by mass per unit volume, represented by the Greek letter ρ, which is often confused with the letter P. Another important characteristic of a fluid is its buoyancy. This is the upward force that is exerted in an object by the fluid it is submerged in. But exactly how strong is the buoyant force, and why do some objects sink and others float? Is it because of its size? No. A tiny coin would sink in the surface, while a large cargo will float. The answer to this is outlined in the Archimedes Principle, which states that any object that is submerged in a fluid will experience an upward buoyant force equal to the weight of the displaced fluid. The buoyant force will support an object if it is less dense than the fluid, for the weight of the object will then be less than the weight of an equal volume of the fluid. This is why a cargo ship, no matter how massive it is, it will float in the ocean. Although steel is very dense, but the air in all the cabins is not. Thus, the ship is less dense than water. But if there's a chance to get the air inside the ship and shrink its size, it would definitely sink. In this way, the buoyant force can be expressed as the gravitational force of the displaced fluid, which is equal to the mass of the displaced fluid times acceleration due to gravity. A floating object displaces fluid based on its mass, whereas a sinking object displaces fluid based on its volume. So, apart from the buoyant object, Archimedes was also the first to understand that when an object, like a person, is submerged in water, the volume of water increases exactly as the volume of the person, regardless of its shape. This concept was discovered by Archimedes during his Eureka moment during the 3rd century BC, when he was working on a project by King Hieron of ancient Greece. This project was on unprecedented scale, wherein Archimedes was asked to build a ship 50 times bigger than the ancient warship, which would be named as Syracusa after the city. This ship was to be the biggest ship of that time, destined to be given as a present for Ptolemy in Egypt. But can a ship of this enormous size float? During this time, it seemed to be impossible. He coined this concept when he was being submerged in the bathtub. He figured out that when an object partially immersed in a fluid is buoyed up by an upward force equal to the weight displaced by the object. This was the Eureka moment, wherein he was said to be running on the streets shouting Eureka, which translates, "I got it." So, if a 2,000-ton Syracusa was displaced in a 2,000 ton of water, it would just partially float. If the volume of water is doubled, it would fully float. If the volume of water is halved, it would definitely sink. This is the law of buoyancy, or Archimedes'